Vectors. Right. If you're trying to navigate around with vectors, you need to work out different ways in which you can get from one place to the other. So if we want to get from A to C, there are different ways of doing it. We could go along here and up here. The problem with going up here is that it's not actually a direct relative of this vector. It's not y, and it's not x either. It's a reflection of x in the y-axis, but there's no simple way of expressing that. Basically, we can only move in this direction or backwards in this direction, or in this direction or backwards in this direction. So the only sensible way we can get for a combination of a and y to c is up here along x, and then across here, which is obviously parallel to y, so it's going to be some multiple of y. In the question, the clue is here. It tells you that BC is double AD, so effectively that is equivalent to 2 lots of y. So to get from A to C, we can go along 1x and then 1y and then another y. I could have just written 2y here, but I'm just making the point. So that becomes x plus 2y. Now, if you're writing vectors, you should underline it to show that you mean a vector. In textbooks and in exam papers, these x and y's to denote vectors will be in bold, but you can't write in bold, so you have to underline it. To get from D to C, well, again, we can't go along here because it's not, x is in this direction, so that would mean moving in this direction here, and y is in this direction. So we have to go along this route. So we go from D back to A, which is minus y, plus an x, plus a y, plus another y. Well, the minus y and the plus y cancel out. So effectively, minus y plus x plus 2y, we can write this out, minus y plus x plus 2y simplifies to just x plus y. So that is our answer. It then says the point E is such that AE equals x plus y. Well, where would that be? That would be equal to x plus y. So E would be here, halfway along BC. And that's not halfway the way I've drawn it. Use the answer to part A2 to explain why AECD is a parallelogram. Okay, well let's make AECD a parallelogram and draw in the extra line. It says use the answer to part 2. Well, A part 2 says that DC is equal to x plus y. So DC, sorry, DC equals x plus y. DC equals x plus y, and that's equal to AE. Now DC equals AE. We also, so this is, sorry, I'm losing control of this here. That's equal to x plus y, and that's equal to x plus y. We also know that AD equals EC. It's equal to y. And since the opposite sides are parallel, and equal, it's a parallelogram. There may be a better way of explaining this. I would actually check the mark scheme to see what it says, but that's a reasonable justification.